Hello friends, this is Nidhi Gupta from the channel Explore Learn. I have changed my channel name from Learn with Fun to Explore Learn because of some issues that many people have the same name of the channel. That's why I have changed my channel name ताकि आप सभी लोगों को मेरे चैनल जल्द से जल्द ढूंढने पर मिल सके। So today we are going to study about the topic carbon and its compound part 2. I have earlier discussed about some topics of carbon and its compound in part 1. Now I will discuss some topics in part 2. What topics will be covered? These are organic compounds, saturated and unsaturated compounds, straight branch ring arrangement, hydrocarbon compounds and friendly nature of carbon, homologous series, nomenclature of carbon compounds, chemical properties of carbon compounds, and soaps and detergents, and finally carbon allotropes. So today we are going to discuss the most important topics in our video. So please with me in the last. प्लीज़ मेरे साथ लास्ट तक रहिएगा। आज हम लोग बहुत ही इम्पॉर्टेंट टॉपिक्स कवर करने वाले हैं इस वीडियो में। So firstly I will tell you about the organic compounds. So what are organic compound, how they evolved, and what is the history beyond the organic compounds. Firstly, till 1828 it was considered that the carbon compounds or the organic compounds can only be obtained from the living organic matter. That means they can only be found in the organic matters or in the living beings, either in plants or animals. It was assumed that a vital force was required for their synthesis till 1828, but this notion was proved wrong in 1828 by a chemist, Frederick Holler, when he succeeded in preparing urea, that is an organic compound, from ammonium cyanide, which is an inorganic compound. That means he proved that that urea, which is an organic compound, can also be obtained outside the living organic matter, as he has prepared it from ammonium cyanide, an inorganic compound outside the living being. So from then it is concluded that organic compound can also be synthesized outside the organic matter. So a common question arises in our mind that what is a organic compound? So what is a organic compound, and what is organic chemistry? So organic chemistry is the study of organic compounds having hydrocarbons and their derivatives. We will discuss about the term hydrocarbons in our next slide. So roughly you can understand that organic chemistry is the study of organic compounds which have hydrocarbons. Hydrocarbons means that such compounds which have carbon and hydrogen, that have only carbon and hydrogen atoms. So those so those hydrocarbon compounds are those compounds which have only carbon and hydrogen atoms in their compound. So hydrocarbons and their derivatives together form organic compounds, and the study will be called organic chemistry. So what compounds are excluded from the organic compounds? They are carbonates, bicarbonates, and oxides of carbon. They all come under the category of inorganic compounds. So here we will discuss saturated and unsaturated carbon compounds. So what are saturated compounds? Saturated compounds, here C stands for carbon. Okay, C carbon compounds that comes in saturated compounds are ethene, that is C2H6, and propane C3H8, and etc. And likewise in unsaturated compounds, carbon compounds that comes in unsaturated compounds are ethene and ethine. Ethene have molecular formula C2, it's C2H4, and ethine have C2H2. Okay, so here in the saturated compound, we are considering a compound ethane. How the structure of ethane is attained, it is written here, how the structure of ethane is attained. In the step 1, how ethane structure is attained, carbon, as we know that the carbon molecular formula is C2H6, that means it has two carbons. Okay, then the two carbons, how these two carbons form bond in order to make a compound which have their valency is satisfied. So in order to make a carbon compound whose valencies are satisfied, carbon one carbon form a single bond with another carbon. In this way only one valency of both carbon is satisfied. In step 2, these both carbons bonded by single bond get bonded with the hydrogen atoms. Each carbon atom is surrounded is forming three covalent bond with the three hydrogen atoms. Similarly, the second one carbon atom is also forming three covalent bond with the another three hydrogen atom. In this way this structure is attained. You can also see the electron dot structure of ethane. If you count the total number of electrons in the valence shell of each atom, you will find that the all atom are attaining the noble gas configuration. In this way the whole molecule is stable. Sorry for that. Okay, in unsaturated compound, we are taking the example of ethene. So what is the structure, what is the molecular formula of ethene? It is C2H4. So similar to that of ethane, in ethene also the two carbon atoms are forming a single bond, and in this way only one valency of both carbon is satisfied. In step 2, both carbon atoms which are bonded by single bond get are forming bond with the 4 hydrogen atoms. As you can see here, each carbon atom is forming a bond with 2 hydrogen atoms. Okay, in this way this structure is attained. In step 3, as you have seen here, observed in step 2, that the carbon valency is not satisfied. Here one carbon is bonded to here each carbon is bonded to 3 atoms. Okay, this one carbon is bonded to this carbon, this hydrogen atom, and this hydrogen atom, and in this way this carbon atom has total 6 electrons. That means it needs 2 more electron in order to satisfy their valency, or in order to complete their outermost in order to complete their octet. So what will they do now? They will form a double bond between the another carbon atom. In this way both carbon atoms satisfied their valency and they form a stable compound. In this way all the atoms attain a inert gas configuration. Here you can also see the electron dot structure of molecule ethene. So in saturated compounds, what is basically saturated compounds have in between their carbon atoms? They have only single bond. This is the most important point for the saturated compounds, that is these saturated compounds have only single bond between their carbon atoms, and these are normally not very reactive. While unsaturated compounds, the structure of ethene have double bond, or we can say that the structure of ethene have double bonds between their carbon atoms. Okay, also there are various compounds in compounds in unsaturated compounds which have triple bond between their carbon atoms. So both kind of compounds come in the unsaturated compounds. Those carbon compounds which have double bond between them, and those carbon compounds which have triple bond between them. Both kinds of compound come under the category of unsaturated compound. That's why I have said that these compounds have ethene, ethyne also. So another compound, ethyne, which have triple bond in between their carbon atoms, also so another compound, ethyne C2H2, have triple bond in between their carbon atoms. So such carbon compounds having double and triple bonds are called are called unsaturated compounds. They are quite reactive than saturated compounds. So they have unsaturated compounds have both double and triple bonds. So now we will study the different kind of arrangement of carbon atoms which were found in their compounds. So what are their arrangements? Basically their arrangements are straight, branches and rings. So the compounds having more than 3 carbon atoms have possibilities of different carbon skeleton, like butane. We know that the butane molecular formula is C4H10. It has more than 3 carbon atoms, it has 4 carbon atoms. So there are possibilities that different their molecule can form different carbon skeleton. So if they form different carbon skeleton, that means they can form that means their carbons have different arrangement in their molecules. Like you can see that this arrangement is called straight carbon chain arrangement, and this one is the branched carbon chain arrangement. In place of H there will be carbon. Okay, so this kind of skeleton is called branched carbon chain, and this kind of skeleton is called straight carbon chain. Here you are seeing the two type of carbon chain arrangement. And if you have noticed that these carbons in different skeletons have not complete octet. That means their valency is not fully satisfied. So in order to satisfy their valency, they were form bond with hydrogen atoms. So when they form bond with hydrogen atoms, then they form different kind of different structures, different structures or different structural formula of butane. So how they form different structures? How many hydrogens are present in butane? They were 10. Okay, here I have drawn the 4 carbon atoms, and let me draw the hydrogen atoms. So as you can see here, all atoms valency is satisfied. So if we can count the total number of hydrogen atoms, you will find that there are these are 10 and the total number of carbon atoms are 4. So it is the straight chain arrangement of ब्यूटेन. तो दिस इज़ द ये एक वन स्ट्रक्चर नंबर 1 है ब्यूटेन का. एंड another structure of butane So this is the chain form arrangement of carbon present in butane, and this is the second structure of butane. So if you see that that both structures of butane have the same molecular formula. Their molecular formula is the same, that is their molecular formula is C4H10 in both case, but their structure is different. That's why these structures are called structural isomers, as they have same molecular formula but their structures are different. So these two structures of butanes are called structural isomers. So in addition to the straight and straight branches arrangement, carbon atoms are also found in the ring form of arrangement. So the carbon atoms are also present in ring arrangement in cyclic compound. So here are these cyclic compound, and this is, what is this? This is a cyclic type of arrangement of carbon atom. Okay, here is the cyclic structure of cyclohexane. Here all the carbon atoms valency is fully satisfied, and all the carbon atoms and hydrogen atoms octet is complete. Like cyclohexane, benzene is also a cyclic carbon compound but have double bond in them. Here you have observed that in butane there are single bond, in cyclohexane there are single bond, but there are also some compounds which have cyclic type of arrangement but have double bond also. Such compounds name are like benzene. So this is the structure of benzene. This is the structure of benzene, and you can see here there are double bonds between the carbon atoms. So roughly we can understand that or we can say that um, hydrocarbons are those compounds which have carbon and hydrogen atoms. And I have discussed all those compounds which have carbon and hydrogen atoms. As I have told you about butane and benzene and cyclohexane. All these compounds are having carbon and hydrogen atoms. So such compounds which have only carbon and hydrogen atoms are called hydrocarbon compounds. And these hydrocarbon compounds having single bond, double bond and triple bond. Those hydrocarbons, those saturated hydrocarbons which have single bond between carbon and hydrogen atoms are called alkanes. Or those saturated hydrocarbons having single bond between carbon and hydrogen atoms and carbon atoms are called alkanes. Here you can write also carbon and hydrogen atom. Carbon and carbon atoms. Single bond between carbon and hydrogen atoms and carbon atoms. So such saturated hydrocarbons which have single bond between carbon and hydrogen atoms and carbon atoms are called alkanes. And those compounds having one or more than one double bond between carbon and carbon atoms are called alkenes, and those having one or more triple bond between carbon atoms are called alkynes. These are alkenes and these are alkynes. So earlier I have told you about the versatile nature of carbon. So if carbon has versatile nature, then it is obvious that carbon is of friendly nature. So here you can see with this picture, this is carbon, and these are carbon friends. So here you can see here that carbon is very friendly in nature. It can form bond with various elements like nitrogen, oxygen, sulfur and halogens. In hydrocarbon chain, one or more hydrogen atoms can be replaced by these elements in a way that carbon valency remains satisfied. So if we see a hydrocarbon compound, for example, we propane. Okay, propane. What is the propane molecular formula? Propane molecular formula is C3 it's C3H8. Okay, so the molecular formula of propane is C3H8. Now let us draw the structure of propane. since carbon is of um, since carbon is of very friendly nature, so the carbon has a tendency to form bond with various elements like nitrogen, oxygen, sulfur and halogens also. So here you can see the structure of propane. In hydrocarbon chain, one or more hydrogen atoms can be replaced. This is a hydrocarbon compound, and here one hydrogen can be replaced, or more than one hydrogen can be replaced by other elements in order to satisfy the carbon valency. If we replace a hydrogen atom, say with a halogen chlorine, then the valency of carbon will be satisfied if the hydrogen is replaced by the chlorine atom. In such case, these atoms are called heteroatoms. So in this case, the chlorine atom is a heteroatom. These heteroatoms are also present in functional group. Okay, these heteroatoms are also present in the functional groups. These heteroatoms and the heteroatoms present in the functional groups attribute to spatial properties to the compounds in which they exist, irrespective of the carbon chain length and the nature of carbon chain. What does it mean? It means that मतलब कि अगर कोई भी फंक्शनल ग्रुप है जिसमें कि ये हेटेरोएटम्स प्रेजेंट हैं, लाइक क्लोरीन, नाइट्रोजन, सल्फर, ऑक्सीजन, इफ़ कोई भी फंक्शनल ग्रुप है मतलब कोई भी फंक्शनल ग्रुप हो सकता है जिसमें कि ये हेटेरोएटम्स प्रेजेंट रहते हैं, और ये हेटेरोएटम्स और फंक्शनल ग्रुप ये हेटेरोएटम्स और फंक्शनल ग्रुप में प्रेजेंट जो हेटेरोएटम्स होते हैं वो जिस भी कंपाउंड में प्रेजेंट होते हैं उस कंपाउंड को एक स्पेशल यूनिक प्रॉपर्टी प्रोवाइड करते हैं. ऐसी प्रॉपर्टी जो कि उस कंपाउंड के कार्बन चेन के नेचर पर डिपेंड नहीं करती और ना ही उस कंपाउंड के कार्बन चेन लेंथ पर डिपेंड करेगी. दैट मीन्स अगर एक ऐसा कंपाउंड है, दैट मीन्स से फॉर एग्जांपल अगर जैसे कि मान लो कोई ब्यूटेन है, ब्यूटेन में जो है अगर फंक्शनल ग्रुप क्लोरीन है, अगर ब्यूटेन में फंक्शनल ग्रुप क्लोरीन है, हम C4 ब्यूटेन का ब्यूटेन विद हेटेरोएटम क्लोरीन एंड प्रोपेन विद हेटेरोएटम क्लोरीन है. तो ऐसे तो इस केस में क्या होना है, इस केस में ये यहाँ पर ये देखिए दोनों जो कंपाउंड्स हैं, दोनों कंपाउंड्स में सेम हेटेरोएटम्स या सेम फंक्शनल ग्रुप है, हैलोजन सेम फंक्शनल ग्रुप है, और इस केस में ये जो हेटेरोएटम जो इस कंपाउंड को प्रॉपर्टी प्रोवाइड, इन दोनों कंपाउंड्स को प्रॉपर्टी प्रोवाइड करेगा, वो प्रॉपर्टी इन दोनों कंपाउंड्स की चेन पर, चेन की नेचर पर और चेन की लेंथ पर डिपेंड नहीं करेंगी. दोनों केस में हेटेरोएटम्स जो प्रॉपर्टी प्रोवाइड करेंगी वो सेम होंगी. ओके, यहाँ पर जो है 4 कार्बन की चेन है और यहाँ पे 3 कार्बन की चेन है, फिर भी क्लोरीन जो हेटेरोएटम है वो दोनों केस में सेम प्रॉपर्टी प्रोवाइड करेगा. ओके, so here is the table of some of the heteroatoms with their functional groups and their formulas. This is this is chlorine and bromine, and the functional group, they belongs to functional group halogen. Okay, and the formula of functional group is this. Similarly, for heteroatom oxygen, O stand for oxygen. O oxygen is a part of various functional group like alcohol, aldehyde, ketone, and carboxylic acid. Here you can see that the functional group of alcohol is OH, for aldehyde it is CHO, and for ketone it is C double bond O. Here these single lines are representing the valency. These single lines are representing the valency of these heteroatoms. This valency is not satisfied. When they bonded to the carbon atom, then their valency will be satisfied. Similarly, the S heteroatom is a part of a functional group thioalcohols. And what is the functional formula or functional group form? What is the formula of this functional group? It will be SH. So what about the homologous series? From the word homologue, that homologue means the same structure or the same functional group. Okay, compounds like methanol, ethanol, propanol, butanol, these compounds have similar chemical properties. And why they have similar chemical properties? They have similar chemical properties as they have same functional group. And as I have told you earlier, that the same functional group attribute to the same property to all the carbon compound, irrespective of their carbon chain and carbon chain length and their nature of irrespective of the length of carbon chain and the nature of carbon chain. So that's why all these compounds having the same functional group OH have the same chemical properties, and such compounds are called homologous series. In any homologous series, we can see a gradual change in their physical properties but no change in their chemical properties, because they have the same functional groups and same functional groups attribute to their similar chemical properties, but their physical properties will be different. As in all homologous series, with the increase in the molecular mass of the carbon compounds, their melting and boiling point also increases. Similarly, their solubility in a particular solvent increases with increase in molecular masses. So here you can see the table of some homologous compound. You can see here the this is the alkane group homologous series, this is the alkene group homologous series, and this is the alkyne group homologous series. Okay, in alkane, first compound is methane, then ethane, then propane, lastly butane. What you will observe in such series is that the difference among the successive compound will be CH2. As you can see, the difference between the methane and ethane is CH2, and ethane and propane is CH2. Similarly, propane and butane is also CH2. Likewise, in alkene, the difference will also be CH2, and alkyne, the difference will also be CH2. Okay. In alkene, what compounds came? First compound will be ethane. Second, sorry, no, it will not be ethane. It will be ethene, then propene, then butene, then pentene. Okay. In alkyne, it will be ethyne, propyne, butane, and pentine. So after that comes nomenclature of carbon compound. How we name the carbon compounds? The naming of carbon compound is based on two topics. It is based on two topics, or we can say that it is based on two things. First one is its naming depends on the functional group. Okay, its naming depend on the functional group, and its naming depend on the basic carbon chain. The name of the carbon compound in a homologous series is based on the name of the basic carbon chain and modified by a prefix or suffix indicating the nature of the functional group. So the naming of a carbon compound in a homologous series based on two things. First is the name of the basic carbon chain, and then second is the nature of the functional group. How we do the naming? Naming is done in various way. First, in first case, in some of the compound, how we do the naming? For example, in propane. In the carbon compound having 3 carbon atoms, we name such compounds propane. Okay. Second, if a functional group is present in a carbon compound, then it is indicated either by a suffix or a prefix. If you see here in alcohol, that functional group present in alcohol is OH. Okay, either OH is this OH is represented by the suffix -ol in the naming of the compound alcohol. Okay, or we can say that this compound naming is done on the basis of the functional group. Okay, what is the name of this compound? This compound is propanol, as this compound has 3 carbon atoms and they have a functional group OH, and the name of this functional group in the naming of carbon compound is indicated by their suffix -ol. That's why we are saying propanol. So third point is, if the name of the functional group to be given as suffix, then the name of the carbon chain is modified by deleting the last E and adding suffix. For example, in propanoic acid, here you can see there that this is propanoic acid. Here you can see the 3 carbon atoms. Okay, as this compound has 3 carbon atom chain. Okay, the basic carbon chain is of 3 carbon. So while naming of this compound, we will name this compound by considering the basic carbon chain and the functional group. So in carboxylic acid, the functional group is COOH. And the functional group will be COH, and in this the basic chain will be of 3 carbon atom. So the name of this carbon chain will be propane, as it is written here, propane. Okay, while naming of this compound, what we will consider is that firstly we will write the name of the compound on the basis of the carbon chain. So we have written here propane, and then we will subtract or we will replace the last last term E with the suffix oic, which is for functional group carboxylic acid. When we replace this E with oic, then we gave the name to this compound propanoic acid. So its name will be propanoic. Acid. Fourth point is, in case of unsaturated compound, then final ane in the name of carbon chain is substituted by ene or ine respectively for double bond and triple bond. So if we look here, unsaturated compound like double bonded compounds, this is a double bonded compound. So while naming such compound, what we will consider, or what suffix we used? We use suffix "ene" for double bond. So this compound have 3 carbon atom basic carbon chain. So we will on that basis we will term it propane, and then the letter E is replaced by the suffix "ene" for double bond, and then we named this compound as propene. Okay, this compound name will be propene. Similarly, for the triple bond, we use the suffix "ine." So in this case, what will be the name of the compound? Its name will be propine. Okay. So let's discuss about some chemical properties of carbon compound. first of all, we will discuss combustion. So, you have already studied about the term combustion in your earlier classes, that combustion is such kind of reaction in which a compound get oxidized to produce a lot of amount of heat and light. That reactions are called combustion reactions. Most carbon compounds, together with their allotropic forms, burn in oxygen to produce CO2 along with the release of heat and light. Here's carbon burn in air to form carbon dioxide, heat and energy. Here methane, that which is a saturated compound, in the insufficient amount of oxygen produce carbon dioxide, water, heat and energy. In case of unsaturated hydrocarbons, in presence of limited oxygen, they produce yellow sooty flame. Okay, yellow sooty flame with heat, or we can say that black smoke is produced. So when unsaturated hydrocarbon burn in limited supply of oxygen, they produce yellow sooty flame with heat. But what about saturated hydrocarbon? Saturated hydrocarbon in presence of oxygen generally give, what they give? Generally give a clean flame. They are giving clean flame. That means they are undergoing complete combustion. If a compound is producing a clean flame, that then you can understand, then you can conclude that they are undergoing complete combustion. And when supply of air is limited, then it results in incomplete combustion. Okay. Similarly, coal and petroleum, when undergo oxidation, they produce oxides of sulfur and nitrogen. As the coals and petroleum have sulfur and nitrogen in them, and when they get oxidized, they produce oxides of sulfur and nitrogen, which are major pollutants. Okay, we have you ever seen that a candle or LPG in gas stove burns with a flame? I hope you all have seen that. But the coal or charcoal in an angeethi sometimes just glows red and gives out heat without a flame. Why? Why the coal or charcoal in an angeethi sometimes just glows red and gives out heat without a flame, while a candle, LPG in a gas stove burns with a flame? They produce a flame, they don't glow red. But the coal or charcoal sometimes just glows red and gives out heat without a flame. They even don't produce sometime flame. What's the reason behind it? The reason is that जब वुड और चारकोल को हम जलाते हैं, तो उस वुड और चारकोल में इनिशियली जो वोलेटाइल सब्सटेंसेस होते हैं, दैट सब्सटेंसेस जो कि वेपराइज हो जाते हैं, वो सब्सटेंस जो उसके अंदर प्रेजेंट होते हैं वो जलते हैं, और जलते हैं तो वो क्या जलते हैं? एक फ्लेम के साथ, और जब वो जलते हैं तो फिर बाद में वो वेपराइज हो जाते हैं. तो किसी भी कंपाउंड के ऑक्सीडाइज होने पर फ्लेम प्रोड्यूस करने का मेन रीज़न यही होता है कि उन कंपाउंड्स में जो वोलेटाइल सब्सटेंस प्रेजेंट होते हैं, तो वो जब बर्न करते हैं तब वो बर्न होकर ही फ्लेम प्रोड्यूस करते हैं. ओके, बट जो वुड और चारकोल होता है, वुड और चारकोल में शुरुआत में जो वोलेटाइल सब्सटेंसेस होते हैं वो बर्न करके तुरंत फ्लेम प्रोड्यूस करते हैं और तुरंत वेपराइज्ड हो जाते हैं। इसलिए कई बार ऐसा होता है कि हम उस इंस्टेंट में हम ये ऑब्ज़र्व ही नहीं कर पाते हैं, कब मतलब उस इंस्टेंट में बहुत कम अमाउंट में जो है फ्लेम प्रोड्यूस करते हैं, या कभी फ्लेम प्रोड्यूस ही नहीं करते, सिर्फ रेड ग्लो करके जो है बिना फ्लेम के जो है हीट प्रोड्यूस करते हैं, कोल्स और चारकोल्स। अब किसी भी कंपाउंड में जो एलिमेंट प्रेजेंट होता है या किसी भी फ्यूल में जो एलिमेंट प्रोड्यूस होता सॉरी किसी भी कंपाउंड में जो भी एलिमेंट प्रेजेंट होता है या किसी भी फ्यूल में जो भी एलिमेंट प्रेजेंट होता है, वो एलिमेंट अपने स्पेसिफिकली जो है एक अपने स्पेसिफिकली एक फ्लेम का कलर देते हैं। द कलर ऑफ द फ्लेम प्रोड्यूस्ड बाय ईच एलिमेंट और कंपाउंड ऑफ फ्यूल डिपेंड्स अपॉन द एलिमेंट और द एलिमेंट प्रेजेंट इन द कंपाउंड। So what is the reason behind the yellow flame of the candle? What is the reason behind the yellow flame of the candle? We all know that whenever incomplete combustion of um, whenever whenever carbon compounds undergo incomplete combustion, they produce yellow sooty flame. Okay, so what is happening in the case of the candle? So here you can see that this is the structure of a candle. Here is the flame of the candle. This region is the innermost zone of unburnt wax vapors. This is as we know that the candle is made up of wax, and this is the zone where unburnt wax vapors are present. This area is the least hot area, and this area is the so this region is the yellow region, and this is the middle zone of partial combustion. Here combustion is occurring, but it's occurring partially. Okay, this region is moderately hot region, and this blue region is the hottest region. Okay, this blue region is called outer zone of complete combustion. Here the carbon compounds are undergoing complete combustion. So what is happening in the case of candle when it is ignited? When the candle is ignited, then due to heat near the wick, then due to heat near the wick region of candle, the candle wax starts to vaporize. So when they start to vaporize, here unburnt gas vapor starts collecting. यहाँ पे अनबर्नड गैस वेपर्स कलेक्ट होने लगते हैं। जब यहाँ पर अनबर्नड गैस वेपर्स कलेक्ट होने लगते हैं, तो फिर ये अनबर्नड गैस वेपर्स आगे और जो है रिएक्शन करते हैं, और ये रिएक्शन करके अनबर्नड गैस वेपर्स हीट प्रोड्यूस करते हैं, और इनसे जो है अनसैचुरेटेड कंपाउंड्स बनते हैं, और यही अनसैचुरेटेड कंपाउंड्स फर्दर लिमिटेड ऑक्सीजन की सप्लाई में क्या प्रोड्यूस करते हैं? येलो फ्लेम प्रोड्यूस करते हैं। तो यहाँ पे जो है येलो फ्लेम जो प्रोड्यूस हो रहा है वो इन्हीं जो वैक्स वेपर्स हैं, वैक्स वेपर जो फर्दर रिएक्ट करके ये अनसैचुरेटेड कंपाउंड्स बनाते हैं, उन अनसैचुरेटेड कंपाउंड्स के कंबक्शन, जो इनकम्प्लीट कंबशन है, उनके इनकम्प्लीट कंबशन के बीच में है ये जो पार्शियल कंबशन है, इस पार्शियल कंबशन से जो है क्या हो रहा है, हीट प्रोड्यूस हो रहा है और उस हीट के करस्पॉन्डिंग येलो फ्लेम प्रोड्यूस कर रहे हैं। ये रीजन हमारा मॉडरेटली हॉट है और दिस रीजन इज अ ब्लू रीजन एंड एज आई हैव टोल्ड यू दैट clean blue flame or a clean blue flame is produced when a compound undergo complete combustion, when a compound undergo complete combustion. So here the blue flame is produced, that means here complete combustion is occurring, complete combustion of carbon compounds are occurring, and this reason is the hottest reason. So I hope you are clear about what is the reason behind the yellow flame of the candle. So one more thing I have to tell you that आप लोगों ने ऑब्जर्व किया होगा कभी भी जब कभी आप कोई बर्तन रखते हो गैस स्टोव के ऊपर, तो आपने ये ऑब्ज़र्व किया होगा कई बार वो बर्तन जो है नीचे से काला हो जाता है, ब्लैक हो जाता है। वो ब्लैक क्यों होता है? वो ब्लैक इसलिए होता है, कई बार ऐसा होता है कि जो हमारे जो बर्नर्स होते हैं, स्टोव में जो बर्नर्स लगे होते हैं, वो बर्नर्स जो होते हैं उसमें जो है डर्ट जम जाती है, या वो बर्नर्स जो होते हैं हमारे वी कैन से दैट वो बर्नर्स जो है हमारे ब्लॉक्ड हो जाते हैं और उस वजह से जो है वहाँ पर सफिशेंट अमाउंट में ऑक्सीजन नहीं पहुँच पाती, क्योंकि आपको पता है कि बर्नर्स तक जो है हमारी बर्नर्स जो है हमारी गैस पाइप से जो है कनेक्टेड रहते हैं और वो बर्नर्स में जो है हमारी गैस जाती है, और जब बर्नर्स में हमारी गैस जाती है तो वहाँ पर जो है उन होल्स के थ्रू जो है ऑक्सीजन जो है गैस के कांटेक्ट में आती है, और जब वो होल्स हमारे जो है ब्लॉक्ड रहते हैं तो वहाँ पर सफिशिएंट अमाउंट ऑफ ऑक्सीजन उस गैस तक नहीं पहुँच पाती है, जिस कारण से वहाँ पे कंप्लीट कंबशन नहीं हो पाता है। और इन दैट केस अगर हम जो है वहाँ पर ऐसे बर्नर्स के ऊपर हम अगर कोई यूटेंसिल रखते हैं तो वो यूटेंसिल जो है ड्यू टू इनकम्प्लीट कंबशन वो उस यूटेंसिल पर जो है क्या येलो सूटी फ्लेम जो है वहाँ पे, या ब्लैक स्मोक जा कर के वहाँ पे डिपॉजिट हो जाता है। दैट्स वाई जो हमारी यूटेंसिल्स की जो लोअर बॉटम होता है बाहर से क्या होता है, वो ब्लैक होता है। So the another one chemical property of carbon compound is oxidation. Oxidation is also the addition of oxygen, but it is different from combustion. Combustion always produce heat and light, but oxidation need not always produce heat and light. So carbon compounds can be easily oxidized on combustion. For example, here you can see ethanol getting oxidized to carboxylic acid, and these alkaline KMnO4, alkaline potassium permanganate and acidified potassium dichromate both are acting as an oxidizing agent, as they were giving oxygen to ethanol and converting them to ethanoic acid. So they are oxidizing ethanol. So in this way In this way, some of the carbon compounds undergo oxidation reaction. Another chemical property is addition. What happened in addition? We all use cooking oils in our food. Okay, some we have we all know very well that vegetable oils are good for health. So why they are good for health? They are good for health because they undergo hydrogenation in the presence of catalyst, palladium and nickel. These vegetable oils are basically long unsaturated hydrocarbons or long unsaturated carbon chains which undergo hydrogenation in the presence of catalyst, palladium or nickel to give saturated hydrocarbons. But the animal fats have saturated carbon chains which are very harmful. These animal fats don't undergo any hydrogenation reaction. That's why they are very harmful for us, and we should choose unsaturated fatty acids for cooking. So here you can see the hydrogenation reaction. This is an unsaturated carbon compound having double bond between the carbon atoms. It's undergoing hydrogenation reaction in the presence of catalyst nickel. Basically, in hydrogenation reaction, hydrogen molecules are added to the unsaturated compound in order to make it a saturated compound. Here you can see that all double bonds are vanished and only you can see the single bond. Another chemical property is substitution reaction. The saturated hydrocarbons are usually unreactive and are inert in the presence of most reagents. Some of the saturated compounds in the presence of sunlight undergo substitution reactions. As you can see, in the case of methane saturated hydrocarbon, it is reacting with the chlorine molecule in the presence of sunlight, and what it is producing chloroform and HCl. Here three hydrogen atoms are replaced by the chlorine molecules one by one in order to produce the compound chloroform. So this is a substitution reaction because each hydrogen atom is substituted by the chlorine atom. So this kind of reaction is only shown by the saturated hydrocarbons. So some of the carbon compounds are of commercial use. बेसिकली ज़्यादातर जो कार्बन कंपाउंड्स होते हैं वो हमारे लिए इतने इम्पॉर्टेंट नहीं होते, इतने यूज़फुल नहीं होते, लेकिन कुछ कंपाउंड्स होते हैं जो हमें इंडस्ट्रियल लेवल पे या कमर्शियल लेवल पे बहुत यूज़फुल होते हैं, जैसे कि हमारे इथेनॉल है उनमें से एक. तो क्या है इथेनॉल? इथेनॉल का मॉलिक्यूलर फॉर्मूला होगा C2H5O H. Ethanol, generally called alcohol, it is a liquid at room temperature. So ethanol is a good industrial solvent, and it is used as a solvent in cough syrups, tonic and iodine tincture. ये हमारे कफ सिरप्स में, टॉनिक्स में, और जो हमारे आयोडीन टिंक्चर्स होती हैं जो मेडिकेशंस में, मेडिसिन्स में एज अ सॉल्वेंट यूज़ होते हैं, और इंडस्ट्रियल सॉल्वेंट की तरह भी यूज़ होते हैं. अगर आपने इसका लेस अमाउंट में भी कंज्यूम, अगर इसका आपने लेस अमाउंट भी कंज्यूम कर लिया, इवन आपने डाइल्यूटेड अमाउंट भी कंज्यूम कर लिया, तो इससे आप जो है आपकी बॉडी अनकॉन्शियस हो सकती है. जैसे हम लोग बोलते हैं कि पर्सन ने ड्रंक कर लिया, इज़ फीलिंग ड्रंकनेस. Even its consumption for a long time can cause destruction to health. Pure ethanol is called as absolute alcohol. What do you mean by pure ethanol? Pure ethanol means that it is not diluted. It is not mixed with water. So pure ethanol is called as absolute alcohol. Ethanol react with the sodium and forms sodium ethoxide and hydrogen molecule. Ethanol also undergo reaction with hot concentrated H2SO4 and produce an unsaturated compound, ethene and water molecule. Here hot concentrated H2SO4 is acting as a dehydrating agent, as it is removing the water molecule. It is removing the water molecule from ethanol. Unlike ethanol, methanol is very dangerous. Its trace amount can cause death. It is oxidized to methanol in liver cells, and then this methanol react with the cells and coagulate the protoplasm, and thus affects the body metabolism, and hence leads to various health hazards. To prevent the misuse of ethanol, poisonous substances like methanol should be added to it. Some dyes are also added to alcohol which give it blue color. मतलब कुछ डाइज भी जो है ऐड किए जाते हैं इथेनॉल अल्कोहल्स में, ताकि जो है आप उन अल्कोहल्स को ईज़िली आइडेंटिफाई कर सको. तो ऐसे अल्कोहल्स को जिनको कि मिक्स किया जाता है डाइस के साथ, जो कि ब्लू कलर इम्पार्ट करते हैं अल्कोहल को, ऐसे अल्कोहल्स डीनेचर्ड अल्कोहल कहलाते हैं. जो sugar cane juices are used to prepare molasses which on fermentation give alcohols. जो अल्कोहल्स होते हैं हम कैसे ऑब्टेन करते हैं? अल्कोहल्स हमें जो है शुगर कैन्स के मोलासेस से ऑब्टेन होते हैं. कुछ कंट्रीज़ में जो है अल्कोहल्स को एज ए एडिटिव यूज़ किया जाता है पेट्रोल में. why they are used as a alcohol, why they are used as an additive in petrol? Because in order to reduce pollution, because when petrol together with alcohol undergo oxidation, then it produce carbon dioxide, which is not a big pollutant. In this way the pollution get reduced. Another compound which is also of very commercial use is ethanoic acid. So ethanoic acid belongs to acid group carboxylic acid, and the group of carboxylic acids are weak acids. Commonly ethanoic acids को हम acetic acid भी कहते हैं, और इसे हम ग्लेशियल एसिटिक एसिड कहते हैं. ये हम क्यों कहते हैं? क्योंकि इनका मेल्टिंग पॉइंट जनरली जो है बहुत कम होता है. इनका मेल्टिंग पॉइंट जो होता है नियर अबाउट 17 डिग्री सेल्सियस, या कह लो कि इसको 290 केल्विन भी कहते हैं। तो इनका मेल्टिंग पॉइंट 17 डिग्री सेल्सियस होता है, जो कि विंटर का नॉर्मली जो कि विंटर में टेम्परेचर अटेन हो जाता है। और इस टेम्परेचर पर ये इस टेम्परेचर से सॉरी ये 17 डिग्री सेल्सियस से लेस टेम्परेचर पर ये फ्रीज हो जाते हैं। दैट्स वाई दे आर ऑल्सो नोन एज ग्लेशियल एसिटिक एसिड। 5 to 8% ऑफ इथेनोइक एसिड इन वाटर इज कॉल्ड विनेगर। एंड ये विनेगर आपको तो पता ही है, पिकल्स में जो है एज ए प्रिजर्वेटिव यूज होते हैं। एथेनोइक एसिड्स, सबसे पहले एथेनोइक एसिड एस्टेरिफिकेशन रिएक्शंस शो करते हैं। व्हाट आर एस्टेरिफिकेशन रिएक्शंस? एस्टेरिफिकेशंस रिएक्शंस वो होती हैं जिसमें कि एथेनोइक एसिड इथेनॉल एक एल्कोहल के साथ रिएक्ट करते हैं और क्या बनाते हैं? ये बनाते हैं एस्टर। एस्टर्स क्या होते हैं? एस्टर्स हैव स्वीट स्मेल्स एंड एस्टर्स आर यूज्ड इन परफ्यूम्स एंड एज अ फ्लेवरिंग एजेंट्स। When these esters are treated with the sodium hydroxide alkali, the ester is converted back to alcohol and sodium salt of carboxylic acid. And this reaction is known as saponification. Why this reaction is known as saponification? Because this reaction is used in the soap formation. This is the molecular formula of ethanoic acid. Ethanoic acid is reacting with the NaOH alkali and it is producing back alcohol, that is ethanol, and it is producing the sodium salt of carboxylic acid. This is the sodium salt of carboxylic acid. This sodium salt of carboxylic acid is further used in the formation of soap, which is the sodium salt of long chain carboxylic acids. Next reaction is the reaction with a base. Ethanoic acid undergo reaction with base NaOH to produce sodium methanoate और सोडियम एसिटेट विथ वाटर। यहाँ पे देखिए CH3COH NaOH के साथ रिएक्ट करके CH3CONO प्लस Na प्लस वाटर प्रोड्यूस कर रहा है। Another reaction is reaction with हाइड्रोजन कार्बोनेट्स और कार्बोनेट्स। इसमें क्या होता है कि इथेनोइक एसिड सोडियम कार्बोनेट्स के साथ रिएक्ट करके सोडियम सॉल्ट बनाता है, सोडियम एसिटेट्स बनाता है, वाटर बनाता है, CO2 बनाता है। सिमिलरली इथेनोइक एसिड सोडियम हाइड्रोजन कार्बोनेट्स NaSCO3 के साथ रिएक्ट करके सोडियम एथेनुएट बनाता है, जो कि एक सॉल्ट है, प्लस वाटर प्लस CO2 बनाता है। अब हमारा एक टॉपिक आता है सोप्स एंड डिटर्जेंट्स। आप इसमें देख सकते हैं जैसे कि यहाँ पर ये 2 टेस्ट ट्यूब ली गई हैं। दोनों टेस्ट ट्यूब में वाटर है और दोनों टेस्ट ट्यूब में वन ड्रॉप ऑफ ऑयल जो है ऐड किया गया। सो इन टेस्ट ट्यूब 1 soap is added and in test tube 2 soap is not added. So what will you observe in test tube 1? When soap is added to test tube 1, oil get dissolved. Here you can see that an emulsion of oil with water is formed. The oil droplets, you can see here the oil droplets which are forming an emulsion in water, and in the test tube 2 you can see a layer lying over the water layer. Here no emulsion is formed. Here two liquids, you can see the two layer of liquids which are not which are not miscible. Okay, here in test tube 1, due to presence of soap, the oil droplet get mixed with water. So this is the activity which demonstrate the effect of soap in cleaning. So how the soap show their cleansing mechanism, it can be best understood from this diagram. आप यहाँ पे देख सकते हैं कि ये जो सोप मॉलिक्यूल है, इस सोप मॉलिक्यूल में ये जो आपको ओवल शेप दिख रहा है, ये ओवल शेप आपका आयनिक एंड है. ये एंड जो है हाइड्रोफिलिक है. दिस एंड इज हाइड्रोफिलिक. एंड ये जो आपको टेल दिख रही है, ये है हमारी सैचुरेटेड हाइड्रोकार्बन टेल है, और ये एंड हमारा हाइड्रोफोबिक एंड है. द डर्ट प्रेजेंट इन क्लोथ्स इज मोस्टली ऑयल. आप जानते ही हैं कि कपड़ों में ज़्यादातर जो डर्ट होती है वो ऑयल होती है. क्योंकि जो ऑयल होता है वो पानी में डिज़ोल्व नहीं हो सकता, तो हम उस डर्ट को कपड़े से निकालने के लिए सोप का इस्तेमाल करते हैं. इसलिए ताकि सोप उस डर्ट को अपने अंदर एंटेंगल कर ले और उसको वाटर के अंदर उसे डिज़ोल्व कर दे, और इस तरीके से हमारे कपड़े साफ हो जाएं. सोप का जो हाइड्रोफोबिक टेल होता है वो बना होता है हाइड्रोकार्बन से, और उसकी जो हाइड्रोफिलिक एंड होती है वो होती है आयनिक होती है. हाइड्रोफोबिक है मीन्स फोबिक वर्ड का मतलब होता है रिपेलिंग, और हाइड्रोफोबिक है यानी कि वाटर रिपेलिंग. तो सोप का जो हाइड्रोकार्बन टेल होता है, यहाँ पे आप देख सकते हो इस डायग्राम में, सोप का जो हाइड्रोकार्बन टेल होता है वो हाइड्रोफोबिक होता है, यानी कि ये कैसा होता है, ये वाटर को अट्रैक्ट नहीं करता, ये वाटर से दूर रहता है. और जो हाइड्रोफिलिक एंड होता है, यानी कि ये वाटर लविंग नहीं है ना, ये वाटर लविंग नहीं है. और ये जो हाइड्रोफिलिक एंड होता है, जो कि आयनिक एंड होता है, ये हाइड्रोफिलिक का मतलब होता है ये वाटर लविंग है. तो ये कैसा एंड होता है, ये वाटर को अट्रैक्ट करता है. सो इट इज द वाटर लविंग एंड. अब ये जो मिसल्स होते हैं, ये क्या होते हैं, inside water, soap molecules are arranged the form of clusters in a way that hydrophobic tails are in the interior and hydrophilic ends are on cluster surface. पानी के अंदर सोप मॉलिक्यूल्स जो होते हैं वो क्लस्टर के फॉर्म में अरेंज होते हैं. जैसे कि आप यहाँ पे देख सकते हो कि सोप मॉलिक्यूल्स यहाँ पे क्लस्टर के फॉर्म में हैं, और यहाँ पे जो हाइड्रोफोबिक टेल्स हैं वो अंदर की तरफ हैं, और हाइड्रोफिलिक जो एंड्स हैं वो हमारे बाहर की तरफ हैं, और ये जो हमारा सेंटर में है वो हमारा क्या है, ऑयल ड्रॉपलेट है. तो ये जो अरेंजमेंट होता है, इस अरेंजमेंट को हम क्या बोलते हैं, मिसल्स बोलते हैं. जो सोप्स होते हैं वो हमारे किस नेचर के होते हैं, स्लाइटली बेसिक इन नेचर होते हैं, और ये रेड लिटमस पेपर को ब्लू में कन्वर्ट कर देते हैं. सोप्स बेसिकली होते क्या हैं, दे आर सोडियम और पोटेशियम सॉल्ट्स ऑफ लॉन्ग चेन कार्बोक्सिलिक एसिड्स. Those soaps Those soaps are very effective in cleaning the dirt, but their efficiency gets reduced when they were treated with hard water. Why? Why it happens so? हम जानते हैं कि जो हार्ड वाटर होता है, हार्ड वाटर में कैल्शियम और मैग्नीशियम सॉल्ट्स होते हैं, और जब ऐसे हार्ड वाटर में सोप ऐड किया जाता है तो वो सोप हार्ड वाटर के कैल्शियम मैग्नीशियम सॉल्ट्स के साथ रिएक्ट करके एक इनसॉल्यूबल्स कम प्रेसिपिटेट फॉर्म करता है, जो कि वाटर में इनसॉल्यूबल होता है, जिस वजह से वहाँ पर फोम प्रोड्यूस नहीं। तो ये प्रेसिपिटेट फॉर्म करते हैं पानी में, और जिस वजह से ये फोम्स प्रोड्यूस नहीं, फोम्स बहुत कम अमाउंट में प्रोड्यूस कर पाते हैं। इस वजह से इनकी एफिशिएंसी, क्लींजिंग एफिशिएंसी जो होती है रिड्यूस होती है, और क्लोथ्स का जो डर्ट होता है पानी में डिज़ोल्व नहीं हो पाता, और इस तरीके से कपड़े साफ़ नहीं हो पाते। तो इस प्रॉब्लम को डील करने के लिए हम क्या यूज़ करते हैं? डिटर्जेंट्स का यूज़ करते हैं, और ये डिटर्जेंट्स जो होते हैं दे आर वेरी इफेक्टिव इन हार्ड वाटर। Detergents, what are detergents? Detergents are generally ammonium or sulfonate salts. They are ammonium or sulfonate salts of long chain carboxylic acids. Detergents show effectiveness even in hard water. Here an experiment is shown to demonstrate the efficiency of soap in distilled water. Here 5 test tubes are taken, namely A, B, C, D, E. In test tube A, 10 ml of tap water is added. In B, C, D and E, 10 ml of distilled water added. In B, C, D and E, 10 ml of distilled water is added. In C, D and E, calcium carbonate, calcium chloride and calcium sulfate is added respectively. To all these test tubes, a couple of drops of soap is added. Then all the test tubes are shaked. When all the test tubes are shaked, the foams are seen in all the test tubes. But in test tube B, we can find a lot of amount of foam. Why? As you can see in this picture, the B test tube has a large amount of foam. इसमें बहुत ज़्यादा फोम मिल रहा है आपको। बी में हमने डिस्टिल वाटर डाला था, राइट? तो बी में हमने डिस्टिल वाटर डाला था, और बी में डिस्टिल वाटर और सोप का सोल्यूशन था, जबकि ए में हमारा टैप वाटर सोप का सोल्यूशन था। सी में हमारा था डिस्टिल्ड वाटर एंड कैल्शियम हाइड्रोजन कार्बोनेट। डी में हमारा था डिस्टिल्ड वाटर एंड कैल्शियम क्लोराइड, और ई में था हमारा कैल्शियम क्लोराइड एंड कैल्शियम सल्फेट एंड डिस्टिल्ड वाटर। पर हमें बी में सबसे ज़्यादा फोम मिल रहा है। ऐसा इसलिए है कि सोप जो होता है वो डिस्टिल्ड वाटर में इसकी एफिशिएंसी जो होती, क्लींजिंग एफिशिएंसी सबसे ज़्यादा होती है, जबकि सोप की अभी हमने डिस्कस भी किया कि सोप जो होता है वो हार्ड वाटर में, या फिर हम ये कह सकते हैं सोप कैल्शियम या मैग्नीशियम सॉल्ट्स के साथ रिएक्ट करके एक स्कम बना लेता है, जिस वजह से वो ज़्यादा अमाउंट में फोम प्रोड्यूस नहीं कर पाता जितना कि वो डिस्टिल्ड वाटर के साथ प्रोड्यूस कर पाता है। और इस तरीके से सोप की एफिशिएंसी हार्ड वाटर में और टैप वाटर में रिड्यूस हो जाती है। सो The foam length is long in test tube B, which shows the high cleansing efficacy of the soap in distilled water. This is these are the carbon allotropes. This is diamond, this is carbon 60, and this is graphite. So what are the carbon allotropes? Carbon occur in different forms which have same chemical properties but different physical properties. Such forms are allotropes. Allotropes which have similar chemical properties but different physical properties are called allotropes. So in one of the allotrope, graphite, each carbon is bonded to 3 carbon atom. Each carbon atom, as you can see in the picture, that each carbon atom is bonded to 3 carbon atom. Okay, number 1, number 2, and number 3. So here each carbon atom, here in graphite, each carbon atom is bonded to 3 carbon atom which lie in the same plane, and thus they form a hexagonal array. Thus they are forming a hexagonal array. Similarly, after graphite, in diamond, 1 carbon atom is bonded with 4 carbon atom, and it is forming a 3D structure. Here you can see that 1 carbon atom is bonded to 3 carbon atom. This carbon atom is bonded to 1, 2, 3. These dots are the carbon atoms. So this carbon atom is bonded to 3 carbon atom and they form a 3D structure. Okay, and the diamond is the hardest substance known till date, and the diamond is also the purest form of carbon. While graphite is a smooth and slippery in structure. Also, the graphite is the good conductor of electricity, though it is a non-metal, but graphite is a good conductor of electricity. This is a very important point. Okay, though graphite is a non-metal, but still it is a good conductor of electricity. Another one allotrope is carbon 60. It has the structure of its structure is similar to that of the football, and its name is named after the architect Buckminster Fullerene. Carbon 60 is one of the Fullerene's class of allotrope. It looks like the shape of the dome designed by the Buckminster Fullerene architects. That's why it is named C60 Fullerene. So it's the question time. You all have to answer these questions, and you have to write the options. You have to write the right options in the comment box. Okay. The first question is, butanol is a 4 carbon compound with the functional group. So what will be the functional group in butane? Second, which are the major sources of fuel? A. Nitrogen, B. Oxygen, C. Sulfur, D. Carbon and its compound. Question number 3, propane with the molecular formula C3H8 has a 6 covalent compounds, 6 covalent bonds, 8 covalent bonds, 9 covalent bond and 10 covalent bond. Question number 4, which of the following hydrocarbons undergo addition reactions? A. C3H8, B. C2H6, C. C3H6, D. C3H4. Question number 5, nature of soap is slightly acidic, basic, neutral, slightly basic. Sixth question, large number of carbon compounds is mostly due to catenation only, tetravalency only, both catenation and tetravalency, none of the following. Question number 7 is, reason behind the low boiling point and melting point of covalently bonded molecule is due to A. Strong intramolecular force of attraction, B. Weak intermolecular force of attraction, C. Strong intramolecular force of attraction, and it's D. Weak intermolecular force of attraction. Calculate the difference in the formula and molecular masses for these compounds, and the options are given here. You have to choose one of the right option, and this question is also the sub part of this 8th number question. These have compounds are first allotropes, isotopes. These above compounds are allotropes, isotopes, isotones, or homologous compound. Okay, thank you. Okay, thank you students. If you found my class useful for you, then do like my video and please subscribe my video, so that you can get the notification as soon as I अपलोड माई वीडियो. सो प्लीज़ आप जल्दी से जल्दी सब्सक्राइब कर दीजिए इस वीडियो को, सो दैट आपको मैं जब कभी भी वीडियो अपलोड करूं तो आपके पास जल्दी से जल्दी नोटिफिकेशन पहुंच जाए और आप उस वीडियो को देख सकें. एंड वन मोर थिंग आई हैव टू टेल यू दैट मैं अब ये पीपीटी वाला जो मोड है स्टडी कराने का, इसको मैं चेंज कर रही हूँ, बिकॉज पीपीटी फॉर्मेशन में बहुत ज़्यादा टाइम लगता है, एंड आपकी इसमें जो है बीच में कंसिस्टेंसी नहीं बन पा रही है. सो मैं ढूंढ रही हूँ कुछ एक नया तरीका जिससे आप लोगों का एक कंटिन्यूटी ब्रेक ना हो टीचिंग में, एंड आप लोगों की लर्निंग जो है लर्निंग आपकी कंटिन्यू रहे. सो थैंक यू क्लास, टेक केयर.